All right. So let's quickly review what you went through. So we started working in Matlab, and a lot of the initial concepts will be the simple linear algebra concepts. And we just have to get used to Matlab notation first. How do I enter my arrays and matrices into Matlab, and then how do I manipulate them? That is step one. Step two will then be how do we plot them, because most of the data, until it's actually somehow graphically represented, it's extremely hard to graph. If you just give me 20 by 20 matrix of numbers, I can kind of comprehend first 5 rows of it, and then beyond that, the data just starts going above my head. So it's very important to actually graphically represent the result, and most of the time when you're actually presenting or communicating whatever it is that you were doing to somebody else, you're going to do that using some sort of graphical plot or some sort of, like, I'm going to call that advanced way to represent the data. So rarely you will just send a big matrix of numbers to somebody and say, here you go. Okay, you have to post-process it in some way, also analyze it, and compute something with it that you can actually give to somebody as a final answer. So then we will learn to do that. And then we will actually go even more advanced, is actually now doing something with it and computing for longer time. In order to implement algorithms down the way, we have to know how to tell computer to do certain things repetitively. That's what really comes down to. It's like, okay, do this 1,000 times if this and this condition is met. So you have to be able to translate that sentence to a computer to something the computer understands, and that's what is going to actually be bulk of our work of learning how to program. And then finally, we will also learn some limitations of whatever it is that we're doing on computers. Like, for instance, we know that the pi, or the number pi, has infinite number of digits, but we cannot store infinite number of digits in a computer. Computer memory, however good, is limited. So we will learn what is the impact of such limitations on the stuff that we actually do. And then we will actually move on to learning about the algorithms and solving certain problems so we can actually implement them. So programming and implementing is actually just, the Matlab is just a tool we use. This is not the Matlab class. This class is actually about numerical methods, though everybody refers to it as Matlab, okay? Because Matlab is the essential tool or essential language we're using in implementing those methods. But just bear in mind that regardless of the tools, you should be able to everything that we learned here, you should be able to translate to a different environment, a different tool, which is all in all going to have similar concepts. So with that in mind, let's actually just, instead of doing this review, let's actually do this review in Matlab. So I'm going to open it up. I have by now 3 or 4 versions of Matlab on my computer. For all of the intents and purposes on in our case, it doesn't really matter which version of Matlab you use. So any of them should do. And if you move away from UT and you don't have access to free Matlab anymore, there's a free version called Octave. So it's a free open source software that is basically emulating most of the functionality that Matlab has. So there are ways. So you're not stuck with Matlab only. All right, so let's just enter things manually. I'm actually going to put the diary, Matlab lecture 2, Matlab fundamentals. And it is 9:12. So this, I'm just telling, record everything in a diary, please. And I'm giving it a specific name. So I'm going to actually just enter myself some vectors. My
page here suggests 4, 6, 8 as U.
So this is a row vector, correct? I'm going to get a column vector. Huh? Add a prime, so U prime is 4, 6, 8. One fundamental thing is that I named U, and U prime just executed. It's currently stored in something called answer right here. However, this answer changes. It's basically just a bucket that Matlab dumps the current answer to whatever query I put in there. Okay? So this answer will change. So U prime in itself is not saved. If I want to save it, then I name it something else. I can just say U1 is equal to U prime. And in that case, you can see here in the workspace that there is U1 shows up as an entry. So we have U and U1 in the memory. Okay? If I want to remove everything from memory, I can say clear all. And when I say clear all of this disappears. Often when you run into problems, sometimes it's because there's something kept in memory from before and you forgot about it. Okay? So clear all might actually clean the slate and then you re-execute things again. Yes?
So what did you do with U1?
I said U1 equals to U prime. This better? Okay. And then now if I want to print U, it's going to say, undefined function or variable, because it's not there anymore, I cleared it. Okay. So there are certain small things that you have to be careful about. So undefined function or variable, typically it knows that it's actually, it's not there in the memory anymore. And if it is in the memory, it should show in the workspace. All right. So those are certain basics. Now, if I want to inspect size, okay, what is my dimension? Common problem that you will have is that there will be something about the non-matching dimensions or whatever it is that Matlab complains. So what are the dimensions? I will inspect dimensions with size. Size of U. Oops, maybe I should define it first. If you use your arrows, so with arrows, it's going to actually go and you can search through the previous, whatever you previously typed in that starts with U, and that's kind of helpful for repeating things. So just put an upper arrow. An upper arrow will find the previous. So this is now U, huh?
So that arrow space, the history is never going to be deleted.
History actually has a finite number of entries. I don't know what is the default, but I think it remembers last 50 or so.
Oh.
Okay. And certainly when you reset things, it might get reset. That might depend on your individual computer. So history is not infinite. Okay. There's finite number of the commands that you recently executed are remembered. Okay. Just like they are in your, when you go to your browser and Google search somehow seems to remember what you searched for before. If you wipe that out for privacy concerns, then it will not be able, then you did clear all, okay, and it will not be able to remember. So this is my U, and I can put size of U. Size of U is 1 by 3, it's a row vector. Okay, so this is basic mechanics of putting in vectors. Now if I wanted to define a matrix, I will do so row by row, and every row, in between every row, I'm going to put a semicolon. Okay? So let's type in this matrix A suggested here. It's 1, 4, 5, 5, 3, 2, 2, 4, 7. Oops. So every row is separated by semicolon. So also if you do a mistake and you don't have enough
elements in one of the rows, so I deleted the last one. It's gonna say dimensions of matrices being concatenated are not constant. Sometimes you're wondering what language is Matlab speaking, because it doesn't look like English. So this and this is concatenated in this. Concatenate means to add together. And then this last one doesn't have the same size, so I cannot concatenate. Dictionary word of the day, concatenate. So you thought you knew English. Well, maybe not so. All right. And then, of course, I can do also transpose of A. I can do size of A. Those are certain inspections that I'm going to do. So this is a 3 by 3 matrix. Because it's a 3 by 3 matrix, and my vector U is 1 by 3. Can I multiply A and U? 3 by 3 times 1 by 3. Those inner dimensions don't match, so I can't do it. What will Matlab say if I attempt to? Inner matrix dimensions must agree, so I can't do it. I can definitely do it with U prime, because then I'm going to have 3 by 1, and then I'm actually going to get a result. So this is a way to check on your homework or whatever work you're doing. There are all kinds of built-in functions. Some of them we're going to use more than the others. Size is the most common ones. Linked space, length, zeros are the second most common ones. So what does, for instance, zeros do? If I do zeros of 4 and 5, it's simply going to throw out a 4 by 5 matrix of zeros. This is good when we're actually starting to work on something and you want to initialize, okay, give me this much space. Okay? It's not necessarily that, so if I say zeros of 100, 100, and I'm gonna, so if I put semicolon after that, that means it's not gonna print it, which is useful if you have 100 by 100 numbers. So if I say my A is this, it's fine, it can do that. Let's try 1,000 by 1,000. It can still do that. Let's try 10,000 by 10,000. It can still do that. Let's try. Okay, there are limits. Essentially, this is a little too much memory for my computer. Just a little overboard. My computer is 16 gigabytes. So again, there are limits to it. So sometimes when you know that your application is going to take a lot of memory, first thing you want to know is give a warning to your computer, by the way, this is how much I'm going to need. So we will use zeros or ones or something. Ones will do the same. So ones will do the same. Random will do random numbers between 0 and 1. So this is a way to initialize your data. And sometimes you don't want it to be way too simplistic, so you can do random numbers. And in geostatistics, you will use this generation of input for all kinds of simulation purposes. It's commonly done in petroleum engineering, because often all you have often in applications is you have in your reservoir, you have measurements here and there. You never have a completely measured field. And you need to populate your models with numbers that are realistic, somewhat variable, they're not all constants, and they're similar to what you measure. So the similar can be actually emulated with random choice of numbers in certain range. So you know that you measured permeability of 20 darcies, and then you can populate your entire reservoir model with 20 plus minus 20% darcies or something of that sort. Okay? And these kind of functions will actually give you that modulus. So this is something that you will learn more about in geostatistics. Okay, so these are some useful numbers. So now, we also learned, so there are certain things that you can do, and this is our linear algebra, that are actually extremely easy to do in Matlab. I'm not going to review over those, I just gave an example of multiplication. You can add vectors, you can subtract vectors, you can multiply them by a scalar, you can multiply different matrices, and it's actually extremely, as long as your dimensions match, it's actually extremely easy to do. In Matlab, this multiply sign will equally treat two scalars, like 3 times 3, and matrices, A times B. So that's kind of really convenient with writing code. We can also reshape matrices, so as long as I have enough elements, I can restructure my array so that I'm gonna actually just give it a different shape for different applications. And all of these, reshaping specifically, is useful for input that doesn't necessarily, so it's nice if I name my input zeros or ones or random numbers or whatever it is, but often I have data, and I have, you send me the data that you want me to use in my model, I have to be able to read that data in, okay? Manipulate, understand what it is, manipulate it, and then use it in my algorithm. And that's essentially what this save and load functions that you went through, I hope you went through the whole last week, okay? So basically it's like opening a file and then reading the data in certain sequence and then closing that file and moving on with the data. Now I just want you to visualize opening and reading files. It's actually a little, we tend not to think about it because that's what computer deals with for us, okay? So when you have a Word document that you save something in, you open up Microsoft Word or maybe OpenOffice version of it, okay? And because the file has an extension docx, you come to the Word to be able to interpret what's written in the file and show it to you in a certain way. Every once in a while, you will send it, you have, say you have a Windows machine, you will send it to your friend with Mac machine, and it's gonna be a little garbled, it's not gonna be aligned the way you see it on the screen. And that's this problem of interpretation. So most often we don't like to think about it, we just kind of expect it to work, and when it doesn't, it can be a problem. Now, in its essence, files are written as follows. So basically, at the very beginning, somewhere in the memory, okay, there is start of the file. And after that, there is a contiguous binary array of characters, or zeros and ones, that is characterizing that file. Now, if I look at it in its essence, it's just a bunch of zeros and ones. Unless I know precisely what is stored where and how to interpret it, I cannot read that file correctly. So in essence, if you take your Acrobat reader and try to force it to read .x file, it's not going to do so well, and you're just going to get some garbled information, okay? Because it doesn't know, it's still the same file, the data didn't go anywhere, but you need the rules of what is stored in that file. So very basic, we're really scratching just the surface of it, will be with this opening a text file. That text file typically that comes to you in these assignments will have just simple, it's going to be a simple matrix of numbers. Nevertheless, you will have to go and look at it, interpret what those columns of numbers mean, and then reshape it so it's actually some meaningful analysis. Okay? So don't get frustrated with it, it's just a process that you need to learn about how things are going, because your colleague decided that whatever those columns actually mean something, okay? But it will change from application to application. So again, every possible example, look at the file, figure out what it is that you're reading, what is the sequence of things that Matlab is reading things in, and then reshape things based on the example that you're looking at. Don't try to like learn it as a cookbook. Oh, I gotta go to this step. Okay? So look at the file, and basically when you open the file, you will position at the very start of the file, and then you can actually, if you have a text file, there is a way to read line by line. Okay? What that line contains depends on what actually is in the file, which is the part where I'm asking you to look at the file. And then you can format, if you actually recognize that numbers are in certain format, you can actually scan them in as an array. And do not forget to close the file. I'm gonna again speak from personal experience. If you just use the same machine all the time, probably you're not gonna run into this problem. But Macs and Windows machines and then other types of Unix machines have a different way they mount their file systems. And different way they signal that there is end of the file. So if you don't close the file properly on a Windows machine and send it to somebody on a Mac, they might not be able to read it at all. Even though the owner will just open it up on Windows and say, what's the problem? I can read it. Okay? That's because Windows and Mac don't have the same way to interpret the end of the file, and one might be more cautious than the other. And ultimately, the way they structure files on their disk is different. Okay? So learn to open, read, close. Open, read, close, so that you don't lose the data. All right. So this is just a brief review of what we went over last time. Nigyu did send me the file from Friday. I'm going to upload that video so you can go over it. And I'm also going to give 2 videos from the similar point in time last semester. So if you want to watch those videos as a review, you can. Okay? And now we will actually just move on with the rest. So let's actually now learn how to deal with text. Text is something that computer doesn't care about, but humans do. We communicate in terms of words and in terms of text. Ultimately, text comes down to a numeric array as far as computer is concerned. And we kind of have to sometimes dance in between those. So for instance, we're going to use string as simply like one specific type of array that stores words. Okay? But it's really just a sequence of letters. So I can actually, you can do your name, I'm going to do mine. So I'm going to say first, my first name is, I'm going to do lowercase everything, is Masha. Okay. And you can see that first shows up here. Let me try to see, what does it say, what is the size of it? Oh, so it actually interprets it as a 1x4 array. Okay? So for those 4 letters, and your name might be a difference, it's going to be a slightly different size. And last name is Pradanovic. So size of my last name is obviously different than my first name. Now I can manipulate these things, so I can put it together in some sort of interpretation. I might need first and last name, so I'm going to say name is first and last. And when I do that, this is actually correct concatenation. It didn't leave any space because it really doesn't know that these are names to me. It just does what I tell it to do. So when you do comma, it's just going to put rows of data together into the same row. Okay? For the second row or anything like that, you need to use semicolon. So I don't like this way, so I'm going to throw in a space. And then I can do this. So this is apostrophe, and I left the space in between. So this in itself is a string. Notice that I actually, to define a string, I haven't given this little single apostrophe.
So explain again why there is no space in
Because it just took the first and last and put them together.
Okay.
It doesn't know that they're names to me, so it doesn't think that it should put a space.
But let's say when you plug in the numbers, there's a space automatically between the numbers.
No, that's just the way they're printed. But it interprets. So here it's a matter of interpretation. Each individual letter is not interpreted as a letter, space, letter, space, letter, space to print it out to me. It just prints the entire word because otherwise it would be difficult for us to read. Okay. But in memory, it doesn't leave any space in between numbers 4, 6, and 8 when we enter them. Okay. It just prints them that way for us. So in order to do that, I can do this. Now if I attempted to do the following, so this typically means go to the second row. Again, it really ultimately interprets these as numbers, and because this is 4 characters and this is 10 characters, in the case of my name, it's not going to work. Okay, because it cannot put everything in the same matrix. The cat is vertical concatenation. So again, it's trying to form a matrix. First row of the matrix would be first name, second row of the matrix would be last name, and in my case, it's 4 characters versus 10. It cannot put together a matrix. So even though it's printing text for you, it's really dealing with it as a number. And that's actually the case with any letters. Our keyboards, okay, they actually have what's often called ISO character. And there are different ways to interpret characters. So some of you might actually have Chinese or Korean or some other keyboard. Okay. Those keyboards are different, and different letters are wired to different characters. Ultimately, all of them are mapped to a number. So the same number here, let's say A, something that is mapped, my A is mapped to a number. In some other language, that number might correspond to a different character. Okay, so that's how you can actually switch between different keywords. Again, the computer just prints it out nicely the way they expect it to, but there is some language interpretation going on there. Okay, so basically then you can ultimately work with these. Now, so this is just strings, simple way to deal with strings. And if you wanted to, well, we're going to go through printing them later. There is a way to print strings or to tell computer, okay, interpret this as a string when you're actually printing it out. Okay, so we'll get to that later. Yes?
Why is it that for that one it says apples or just kiwis, but it's still printed out?
Okay, let's open that up. I'll open it up on a... So here there is a space, and here there are 2 spaces, which make them all equal size. So if you want to do that, so I could have actually left 6 spaces in my first name empty. Space is a character. You don't see it, but space is interpreted as a character. Okay. So if you want to force that to happen, and for some reason you want things printed equally, then you have to add spaces. All right. Polynomials are treated separately because they're actually very common in a lot of data interpretation. So there is a special way to interpret polynomials in Matlab. Okay, this is actually something that is somewhat specific to Matlab. It makes it easier to use. It's not always the case in all other environments. So polynomials in general, mathematically, they have a number of coefficients. So I have a coefficient times my variable x to a certain exponent, and then second coefficient, and I keep going. Okay. So this is a general form to write a polynomial. The way Matlab interprets them is going to put coefficients into a row vector. So if I have x to the 3 minus 2x plus 12, I'm going to actually put coefficients corresponding to all of these exponents. So there will be 1 times x to the 3. Then there's nothing actually with x squared. but I need to leave the space in order for it to know what correct exponents are. So it's going to be 1 plus 0 times x squared minus 2 times x plus 12. So let's actually try to define a polynomial like that. And I'm actually just in that diary, I'm going to say define a polynomial. So I'm typing it as a comment that's just going to be ignored by command line, but it's going to be there in the diary when I post it for you. So define a polynomial, and I'm going to say C, my coefficients are 1, 0, minus 2, and 12. So if I actually evaluated this polynomial for 1, okay, my P, if polynomial is P of 1, would be 1 plus 0 minus 2 plus 12. So it would be 11, right? Yes? Well, I can do and just say polyval. So this is a function, and we're going to, that simply, you give it this matrix of array of coefficients and 1, and you're going to get that number 11. Now actually for 1 it was very easy for me to verify that it's doing correct job for 1, because I can do the calculation quickly. I can do something now more complicated. 1.5 or 10.5. It's just going to evaluate the same polynomial for whatever I type in. So this is just a very quick, if you need to deal with polynomials, it's a way to. Yes?
What did it do with 1.5? How did it become? Did it multiply?
It did. So what it did 1 times 1.5 to the third time plus 0 times square minus 2 times 1.5 and plus 12. And indeed, it's the same number. So it has its algorithm that computes the value of a polynomial that is programmed behind this function. And what we will do later on, we will learn how to write a function that executes something that you want executed. Okay? One more thing that is very nice about it. So, okay, I will have a bell log of velocities, and I gotta do something with those velocities. I don't want to type polyval of 1 and then polyval of 2 or polyval of 3 or whatever it is and keep going. Okay? I want to actually execute for an array of values. And you can actually do that. So I can actually say my x is, let's use that linspace. My x is going between 0 and 1, and let's say that I have 20 values in there. Just give me 1 minute. So this is my 20 values in x. I can just say polyval those coefficients in x. And it's going to execute for all of those 20 values. I'm going to get a result. So I can give it an array of values and get a result back. So what I did is this. Okay? And I'm just going to say y equals to.
What does link
It goes and puts 20 equally spaced values in between 0 and 1. No, I forced it to be 20. Okay? Otherwise, if you go off, that's going to stop. Yes.
Oh, diarrhea.
Diarrhea.